So I work at Google. Before that, I used to work at ThoughtWorks. So one of the reasons I'm here, one of the reasons why I'm interested in this is that Google's a very weird company. So we have about 30,000 employees. About 60% of them are programmers. Just about everybody who runs the company is a programmer, which is very different to most companies. And that informs a lot of the stuff we do. It informs our interest in some of the topics I'll be talking about, such as computational thinking. Because now you have a company that's driven by engineers, by programmers, but they have to work with other people. And it's unlike most companies where the programmers effectively serve the rest of the company. This is a programming company and everybody else serves that function, which means it's really important to be able to communicate the values and concepts and understanding that the engineering community has to the rest of the company. And so one of the things I often spend a lot of time doing is talking to other parts of the company and sharing the way we look at the world. The other thing I do a lot of is work with our diversity people. So I mentored an A-level student who, by the way, was scarily smart. And she got a star for a computer science A-level. As somebody who has a politics degree, it's my first degree, it was so unlikely. So we do a lot of work with people we do mentoring, we also do a lot of work in terms of diversity. So I've done sessions with our efforts to get more black kids into programming and into computer science. And so what this talk is going to be about is about programming and computer science, but also how this affects the wider society. So Dave Hoover and I, who also used to work at ThoughtWorks, spent 4.5 years of our life writing that book, Apprenticeship Patterns. So who has heard of software craftsmanship? Excellent. Okay, so there's a long riff I could go on about software craftsmanship, but we'll summarize it that in the book we try to talk about this notion that skill is really important, that we tend to focus on knowledge rather than skill. So in the book we try and talk about the importance of acquiring, developing, and transmitting skill, and how that's really vital for programmers and for anybody in general. So the distinction we make between knowledge and skill is that skill is you can build something, but you can build it well, and then you can show other people why it's well made. And so this eventually leads to what we call a craft. So the distinction that's really important between craft and art is that for us, art is about self-expression, but craft is a lot of the elements that go into art, but attached to the notion of utility. It can't just be beautiful, it has to be useful. And it has to be useful to somebody. So when we talk about software and we talk about software craftsmanship, we think about utility, serving somebody else, serving a community. And so one of the things we feel is important about apprenticeship is trying to teach people about how to use their skills to serve a larger community than themselves. So the distinction I suspect between software craftsmanship and software engineering is that this is not just for somebody to learn in isolation or in a university environment where you go in, you study, and then you leave. This is about becoming part of a community where other parts of the community will teach you the things they know, the things they're good at, but then you'll be expected to share that knowledge, those skills with other people so that we each teach each other. So when we talk about apprenticeship, and I should point out my co-author, he helps run a company called Autophagy, and one of the things they have is an apprenticeship program, which is where they take people, a lot of whom come from non-traditional backgrounds, who want to become professional programmers, and they apprentice them to somebody who's an experienced programmer. And they work with that person. So there's an apprentice and there's somebody who works with them on improving their skills and making them a viable member of that community, that company. Autophagy recently got acquired by Groupon. But the thing about apprenticeship, and the thing that Dave and I care a lot about with apprenticeship, is that it's not just merely teaching somebody, it's giving somebody the tools to teach themselves. Anyway, buy the book. Or you can download it for free, since we can make it available for free online.
No, buy it.
So, yes, if you buy it, I might actually make back the advance. So, what I'm mostly going to be talking about here is the new directions that we think people should look at in terms of changing the way we do education for programmers and for everybody else. So there's a woman called Jeanette Wing. She used to be at CMU in America, and she's been leading, they have a group there who's looking to something called computational thinking. Now, we at Google are heavily focused on university students because that's where a lot of our employees are coming from. We're less focused on secondary school, like Simon Peyton-Jones was talking about. And so for us, when we think about computational thinking, so computational thinking is the idea that there are techniques and habits that computer scientists have which are beneficial to other disciplines. So things like being able to think algorithmically, things like functional decomposition of problems, things like stepwise refinement, things like modularity. These are all things that are beneficial to other communities. So my first degree was in politics, my second was in computer science. And the thing that I noticed when I switched, now I actually went to Queen Mary College, so if you know it, it's a long, long strip along Mile End Road. The arts faculty is at one end, computer science, physics, and all the other stuff is at the other end of the road. So literally, you walk about a mile down the road, and things like the gender balance and the ethnic mix of the people change down the road. So that by the time I walked from the arts faculty, all the way down to computer science, it's a very different world. In the arts faculty, when I was doing my undergraduate degree, I had to talk to the head of the faculty to get a Unix account. And he didn't know what a Unix account was. This is 95, 96. And I had to get the form, and he said, what is this? It's a Unix account, I need your signature. Why do you want it? And I had this, I wanted to say, well, it's because at my job, I need TIN, I need to be able to log back into Unix server so I can read my email. And I thought, I'll never explain that. I just say, I need it for the job I'm doing for the summer. And I went, okay, and signed it. So the funny thing is, when I did my master's thesis, which was on how people like politicians who have diaries can move from a process where they write their diaries and they hire students to type it up to some kind of automated system, and I did that in cooperation with the politics department, I was able to look at a lot of the stuff that was being done in the arts faculty and see how computer science and computational thinking could really help. So things like this psephology, studying of how elections are run, those are unbelievably manual. They pay students very little money and they go through the election results manually and type them up. There are things there where they just simple things they could do with spreadsheets, simple scripts could make a massive difference to the stuff they do. Things like the history department, where being able to collate the data they've already gathered and analyze it and compare it and share it with other departments, other countries, which also are studying. So for example, if you're studying the history of the Prime Minister or the Office of the Prime Minister over the last 50 years, wouldn't it be amazing if you could compare that with similar data from New Zealand or from other countries that have prime ministers? But of course, you need to have that data in a computationally tractable format, which of course they don't. So computational thinking is also really important to Google because if you have an entire company that's mostly programmers, if you can export the habits of looking at the world of those people to the rest of the company can become a lot more effective. If you look at something as simple as the way the company makes money, which is advertising, the simple insight that means that we make a lot of money is realizing that you could have an auction where the person who pays the most money gets the advert shown, but the advert will tend to be irrelevant and not very good. Won't be clicked on, which means the advertiser loses out, the user loses out, the search engine loses out. And somebody looked at auction theory and said, if you did a second price auction, so it's the second highest bid that wins, you pay the price of the second highest bid, not your bid. And then if you also took into account relevance and landing page quality and a few simple metrics, you get much better advertising. Now this is not a computer scientist thinking this is an economist. But they were able to think like this because they'd spent enough time in computer science that they could absorb a lot of the concepts about how you can do calculations. And suddenly you have a multi-billion pound business. And so one of the things that's really important to us is about how you include more people. And unfortunately, a lot of computer science education is very good for the people who immediately grasp the concepts, but it's very bad for the people who don't. So if you study at university and you use structured interpretation and computer programming, and you immediately get the ideas, fantastic. If you don't, you basically are out. So when I was at university, I spent a lot of time helping with the remedial computer science classes. And there were people who, in the first week, the first month, they missed some basic concepts about how to compile code or what a class was. And then the rest of the year was just wasted. Because without that foundation, without the foundation of computational thinking, or what is a pointer, what is a state machine, how do I refactor, how do I modularize, without that, everything else you do doesn't make any sense. So one of the questions I'd like to ask you guys is, when we talk about educating programmers, isn't that a little unfair? Aren't we excluding everybody who doesn't want to be a programmer? And should we actually be thinking about how do we include more people in computational thinking? The other thing, and this is something I got from my time at ThoughtWorks, was the question of, are programmers instruments for other people's wills? Are we just human compilers? If the customer could code the solution themselves, would they still hire us? Or perhaps should programmers be auteurs? Should they own the program, the thing they're trying to build? And if you look at a company like Google, the thing Google has is that for Larry and Sergey, they are the authors of their own story. The company is effectively an extension of their will. And for a lot of programmers, that isn't true. For a lot of programmers, they do whatever the customer tells them, even if that's not necessarily the best solution. Often the customer has a rough need, but actually, if they had a little computational thinking, they could actually see bigger opportunities. But of course, the programmers just do what they're told.
Can you give an example?
So I'll give you an example from Dixon's, the ThoughtWorks project, where we had a database report that was taking a long time to do. It was taking about an hour to run, and it was 60 pages of the data. And eventually, I got sick of this, and I called up one of the bigger branches of PC World and said, what are you doing with this 60-page report? Because it's killing us trying to optimize it. And they said, well, what we do is we print it out, then a guy with a calculator spends about an hour summing up the numbers. And I said, you know what we do? We start out with that one line, and then we write this hugely complicated SQL query that expands it out into that 60-page report. And the guy said, well, what if you didn't do that? What if you just gave me the results you already have? I'd save an hour a day. We went, well, we could do that. I just deleted a ton of code. And the problem was that in writing the requirements, the people behind that hadn't fully grasped the entire picture, and they couldn't easily see how computer science could change the nature of their work. A lot of the stuff we did at Dixon's was actually talking to people in shops and having a conversation where we would say, we could do that for you. And getting them to say, well, is it possible to do this? And we say, yeah, sure, that's actually a built-in function. And having that conversation. And imagine a world where the customers are actually people who have an understanding of computer science. Imagine the things they could ask for then. It's not enough to just implement the requirements. You've got to get them to think bigger. And that's only possible if society changes to become a place where everybody is at least familiar with computer science. And if you think back to the olden days, where if you wanted to write a letter, you found a guy, you dictated the letter to him, he wrote it, and then he said, this might be better as, and he would help you rewrite it. You send it to somebody else, who would have somebody read it to him. And what we have now with computers is exactly the same world. In 10, 100 years' time, when everybody programs, we'll look back on today where you had specialist programmers in the same way we had specialist scribes, and it'll seem weird.
Does that hold? I'm just thinking the same old metaphor of building. We all have some idea of how a building is put together, but not all of us are builders or architects. And even though we're now how many thousands of years into building technology, we still don't have a world in which everybody does building.
I suggest if you ask a 3-year-old, they would disagree with you. And I think the thing about the scribes metaphor is that today, a large number of people, at least in the Western world, write and read. But we still have professional writers. This is the future that I see for programming, where everybody programs. But some of us do it well enough to get paid for it. If you think back to how switchboard operators used to have a living, connecting people. And what do we do now? We make everybody a switchboard operator. Everybody has to remember area codes.
If programming includes programming your video recorder, perhaps everyone does program.
Nobody programs it.
Yeah. You haven't met my wife.
The other thing I wanted, so I'm mostly trying to sort of show people some possible new paths we could take. One of the ones that I find most interesting, and it's something we stumbled across in the 4.5 years of research for the book, was that a lot of people, they want to teach students. But the thing is, a lot of the students have things they want to learn, and often there's other things that people want to teach. And this is a real struggle. So you get people who come in and they are passionate about something, but that's not what's on the curriculum. So the girl I mentored, one of her motivating drives was that she wanted to know something her father didn't. Her father's a programmer at Cisco, and she was just sick of the fact that he always knew everything. And she basically sort of worked with me, and she built a Python and MySQL app for doing high-dimensional feature analysis of Wikipedia as a feature space. Because when she talked to her father about this, he didn't know about high-dimensional analysis of high-dimensional feature spaces. She had something he didn't know, and knowledge was power. But that's only possible in an environment where you can actually say, this is the stuff I want to learn, and the person who's in the teacher role actually facilitates and points you to knowledge rather than pushes knowledge at you. So I'm just going to finish by saying I think we need new kinds of programmers. So obviously one of the things that's a big driver in my book is the idea that programming is a skilled craft, which means we need to think very carefully about what are our skills. There's a book by a person whose name I've forgotten right now, but he works at Panic Software, and it's called How to Count. And he's writing a series of books teaching people, starting from knowing nothing, basic concepts. So his book, How to Count, is actually about number theory and bases and binary and all those little things which programmers use, but which other people are interested in, but which they'd like to isolate from the whole programming edifice. They don't want to learn C, but they might be interested in the numbers and why is my hard drive size not the size I thought it would be. There's a bunch of interesting knowledge there, which if you can find a way to pull it out and give it to people, it will change the way to look at the world. Yeah. So I think programming is creative, but only if you, as the programmer, are the auteur. If you get to choose the things you make, why you make them, what they're made for. And then the other thing is that I think programming needs to become discursive. So one of my hobbies is photography. And the thing about photography is you need to be able to have a language for describing what you've done, aesthetically, creatively, and also so you can actually talk about improvements. So I had a photography teacher, and she was rather brutal by the idea that you were to tell her, why is this photo better than this photo? And not hand-wave, you have to explicitly be able to say clearly, because you need to have that thought process. And we don't yet have that in programming. We can't discourse about programming. We can't say why this code works better than that code. And we can't explain that to other people. We don't have a literary theory of programs, but we should.
One of the things we do when we train programmers is we spend an enormous amount of time training them on how to comment their code.
Exactly, how to talk about the code rather than just simply repeat what the code says.
And isn't that, I can't think that's slightly overstating the case. I mean, wasn't the whole patterns thing about having a language in which we could describe at a sufficiently high level things that were happening in code and make exactly these sorts of comparisons?
I think so. That's what it started out as. If you look at a lot of Alexander's stuff, he was talking about how patterns would enable people to control their environments, their homes, and be able to actually specify things about the design of their houses they lived in.
Well, and like a lot of that, effective languages of this sort of has two sides. There is an analytical side of it, but there's also a generative side of it.
Yes.
And that's the key to the early work of patterns and software, I think. And maybe we lost the plot with that, and maybe we started it moved to the analytical rather than the
Absolutely.
generative.
Yes. Sadly, the patterns movement went a little wrong, and it became description. It didn't become a literary theory, a thing that would let you talk and criticize about the code.
What's the title of your book, Daniel?
Apprenticeship Patterns. And yes, many people have sort of lined up to criticize our book and say, I don't really think this is sufficiently generative to be patterns, or I don't think this is enough, and it's not quite a pattern. And And we had that debate.
Yeah, but the point is these are ways we build languages to talk about the things that we do, and I think it's important to remember that.
So the other reason I think we need new kinds of programmers is that we need people who can actually appreciate the beauty of a program, or the beauty of the thing the programmer is trying to achieve when they build something. And currently that's very hard for people to do. They can look at your application and say, well, the graphics look pretty, but that's it. It would be like if somebody saw a painting and said, yeah, it's red. We need more than that. We need to appreciate the beauty of a program, but also we need to understand the utility of it as well as the beauty. And I think this lack of appreciation within programmers as a culture, but also within wider society, is one of the reasons we struggle to educate programmers. It's one of the reasons why I have friends, female friends, who in the 80s wrote assembly code, and who today do very complicated things with Excel, with SQL, but they tell me, oh, I'm not a programmer. And I say, I was there, you wrote assembly. They say, oh yeah, that was just, child stuff. It wasn't programming. People now who do things that I consider programming tell me they're not programmers, because there's something wrong with being a programmer. And I think it's a mistake to talk only about educating programmers. It's more about how do we make everybody a programmer. Because if you do that, you get a world where a course that only teaches you how to use PowerPoint isn't seen as useful. Just like a course that taught you just how to type wouldn't be seen as sufficiently useful. You'd say, it's not enough in an English literature course to teach you how to type or how to write, by showing you how to form letters. They want you to learn how to express yourself through the medium of language. And I think one of the things we need to teach society is how to express itself through the medium of programming.
Ade, I on a very scrappy piece of paper, I wrote down some questions in the hope that they might come up. And there were a couple of questions I wrote down that I wouldn't mind putting to you, actually, and maybe to the group, relating to your what you're talking about here. The first question was, when I and I say this to everyone, when I learned how to program, I didn't learn how to program because I wanted to learn how to program. I'm not sure that very many people do, at least not people that I would socialise with. I learned to program because in the early 80s that's how you operated computers, and particularly because I was interested in writing my own games and learning how to write the games that you read about in those wonderful magazines that we don't have anymore. So I was wondering whether, rather than talking about teaching computing in schools explicitly, as that's a separate subject of its own, should we be looking for ways to complement other subjects like physics, maths, art, music, with some element of some computational element, programming or data processing or whatever?
Absolutely. Programming is a means to an end and not an end in itself. This is the thing I think we're in danger of losing.
I'm not so sure that that's true with a certain section of the population, many of whom work as my colleagues. I think that one of the joys of programming is actually it's a bit like playing chess. And I sorry Jason, but when I learnt programming, I did it because I fancied doing the programming and making something work. And one of the things that keeps me up until the early hours of the morning, if not late hours of the morning, is actually making something work and worrying away at it until it works. And I think for, as I say, a subset of the population, that is one of the really motivating things. It's not that you're making a neat app that does something fantastic, but that's a great result. And you can show it to your friends. But if you've got any. But the other thing, the thing that keeps you from minute to minute is actually making the next bit work and thinking, what should that next bit be? And I think for many people, that is part of the fun. And in terms of some kids, at any rate, if I'm thinking, well, how can I convey the fun and excitement there is in that? It's about showing them, getting them hooked on that.
The problem is that only reaches a very small number of people. And if you think about programming as a new kind of literacy, there are 7 billion potential programmers on this planet. And if you focus on just the fun of the problem solving, you get a very small number of them. And you end up with the kind of program classes we have now, where you look through them and you say, wait, I walked from one end of my lane to the other and suddenly all the girls disappeared. What happened?
But you see, I think you're right. I agree with you to some extent. But I also think that the other thing is also true, that there's a and there is a spectrum. But I think that the general literacy that you're speaking of, I think that sounds like a great thing, and I'd really go for that.
It has to be.
But it isn't the only part of the story.
Absolutely.
But if, Alan, if we view programming, for example, as a life skill, which maybe what it should be to some extent, that everyone can program well enough. Like when I did my physics degree, for example, a lot of us had to learn how to program to a standard in order to achieve some computational mathematical goal or whatever it was. Some of us discovered in doing that that bizarrely we really enjoyed the programming bit. And I think the more people who get to try it, as it is with language, not everyone's going to be Noam Chomsky, but it's good to learn a language, and maybe some of those people who learn languages will discover that there is an inner linguist within them. So I kind of worry, I agree on one sense. I agree that if people genuinely are gravitating towards the problem-solving element, then we shouldn't stand in their way and give them all the support they want and have that standalone subject for them. But I think Ade's right. I think for the majority of the population, there's an end result, and maybe in doing that, some of them will discover that actually getting to the end result is a really enjoyable process, and they're the ones, hopefully, who will go on to study computer science at university and
teach themselves anyway.
Yeah.
And so I worry sometimes that we tailor our educational courses towards people who would teach themselves anyway, and the people who need to be taught don't get any help.
I don't think that's true, and I think if we think that, well, they would teach themselves anyway, then we're actually starting off on the wrong footing. I do like the idea of a curriculum that really does, in some sense, encapsulate all this knowledge, but also the joy of making. I think that, the analogy with reading, I'm not learning my alphabet when at the age of 14 I'm reading about King Henry VIII. That's the life skill thing. That life skill is already learned. And if we're talking about embedding computational thinking as part of the way we think and talk about stuff, then we need to start teaching that very, very much earlier. We shouldn't be talking about secondary school. We should be talking about primary school. We should be talking about some of the things that we were talking about earlier, and so the sorts of software that kids are using in primary schools.
Nice.
And there's an explosion of interest in that.
I've got one question, which is you're doing a nice lead-in for his next
And just to add one thing, and there's the pioneering book on this, and I've talked about this with a couple of people today already, is the Seymour Papert book, Mindstorms.
Yeah.
Every time I go back and read that, I'm just blown away by the vision.
Have you looked at Scratch and what's going on the Scratch website?
I have, yes.
Well, I mean, I think that's where I'm quite optimistic, because I slightly disagree with your point about it's a limited number. That site is heaving with thousands of people of different races and both genders doing stuff, enjoying, creating, sharing, hacking,
creating what
about.
Though? What are they creating? Are they creating
Some
computer
of it is
programs?
total crap.
Are they creating computer programs? Or are they creating games or presentations
all sorts of things, everything you can think of they're creating, and some of them are dire and that, but there's a self-help group that will go on and criticise one another's things and help one another.
But my question is, why are they doing it? My question is, are they doing it because it's programming, or are they doing it because there's a game at the end of it?
It's like I did Hypercard. It's not about programming, it's the joy of creativity. It's your craft. Craft is now a dirty word. It's been a dirty word for 20 years in education. And that's, in a way, they're discovering craft for themselves, because they sure as hell aren't getting it at school. Because we got ruled out. It used to be craft design and technology. Craft got struck out.
It's also challenging.
It's challenging,
anything else you do
problem
in school.
solving,
My introduction of Scratch with a group of pupils in the term before summer holidays has led to them doing stuff that they've come up to me and said, we've never done anything like this anywhere else in school, where it's risk taking is encouraged. which is something that kids don't do enough of, because like Giver Tully's tinkering school, if you've seen the TED video, that there isn't enough of that sort of risk taking, although it's kind of mild in the use of Scratch or whatever, but they love the fact that whichever one of you gents said about trying something and doing the next bit. So once they've made a level in Scratch, they want to know, how can I make another level? Is it possible? And if it is, how can I do it? I want a counter or a timer on this. Can it be done? And if it can, I want to learn how to do it. That's where the motivation comes, is the sort of challenge rather than that it is programming at the start of.
And it's exactly the same thing that Hypercard tapped into in the late 80s and early 90s. And it keeps coming around and going because there isn't something to institutionalise it, if that's a horrible word, but it's more about the problems of education in coping with that and adopting it and building it into what we do. There aren't mechanisms for that, really. It happens externally, not inside. There's people like Ian going to tell you how he's doing it, but there aren't enough of them.
Well, I think the one reason why Scratch is so successful is because it addresses exactly the problem that we were discussing before here, about that there are many different motivations and many different levels of ability out there, and what Scratch gives you is the ability for self-directed learning and self-paced learning. And even at university level, where we already have a very strong pre-selection of those who enter a computer science degree, we have a huge breadth of motivations and ability. And it's even more so at school level, where it ranges from the really good and motivated to some who aren't motivated at all. There isn't a single approach that works for everyone. So if you try to answer, why are they programming, there isn't a single answer. It's not because they are interested in technology or because they are interested in the end result, because there's some in either camp, and there are probably 15 other camps as well. So I think the one thing that Scratch has enabled is that you do not rely on there being a single answer, because it enables a very much self-directed working. There is an answer for everyone, and we have to realize that there are many different motivations out there and many different levels of ability.
And I think that's best illustrated with what you've just said with an example where I gave my pupils a survey of how they were being taught and what they thought I was doing. And one of the questions I asked was, how have you been taught by your teacher? And what my best pupil gave me a 1 out of 5, and 1's the worst. And I sat down to help her. I'd sat and devoted loads of time to help her. But what she wanted to do was something I couldn't help her with. What she was trying to do in Scratch, I wasn't there yet. And when I said to her, look, I hope you don't mind, that survey was meant to be anonymous, but I know. I said, I hope you don't mind, but give me a 1 out of 5. I sat down for an hour with you over 2 lessons, and you give me a 1 out of 5. She said, that's because you didn't know the answer. I tried to help her, but didn't know the answer.
But isn't that the problem with having a teacher rather than somebody who says? So one of the metaphors we use in our book is this notion that there's a mountain, and you'll see people who are further ahead of you, and that just means that they know what's around the next corner. That doesn't mean they have a map of the whole place. And so you have much lower expectations of other people.
I mean, this is excellent. I had a similar experience. I was teaching on a course where we did a very strict problem-based learning approach, where we never gave answers to the students. We just, pointed them in the right direction. And when they asked something, we always asked back, how would you go about finding out? And at the end, we did a similar thing, a survey, and a student said, well, I learned a lot, but they didn't teach me anything. I had to do it all myself. and we thought that is exactly what we wanted to hear, but he didn't know that.
I have one question, just coming back to the point about beauty and appreciation. I completely support the point that we need to extend computational thinking. The thing that I've always struggled with people who've never programmed or who've only just started, is how do you explain to somebody that code is beautiful or elegant and that one isn't?
So this is one of the things we don't have. You have sort of a bunch of things you can convey to them depending on their background in terms of things like aesthetics, things like simplicity, minimalism, symmetry. There are concepts of aesthetics that transcend any particular discipline, and those apply to programming as well. And of course nobody's actually really done this, Nobody's found ways of explaining to people that things that avoid duplication are considered beautiful. Unnecessary ornament can sometimes be beautiful, but ornament can sometimes also be beautiful itself. I'm going to explain that in code. I'm going to say that the Pearl Gold people believe that ornamentation is beautiful, and thus this code does this complicated thing to achieve this simple goal. You can achieve just as simply here. But in their community, their standards of aesthetics say that this is beautiful. Having that language is something we don't have. It's something we haven't spent enough time on.
I'm not sure that's true. I think in terms of aesthetics, I would agree. I think in terms of the, if you like, physics of code, I think we understand it very well. We understand the impact of duplication or complexity or dependencies. So I think we have, if you like, an engineer's understanding of how much harder it is to change something if someone's copied and pasted it 20 times. So we understand the impact of it. But in terms of a more, if you like, a more esoteric language for it, I would agree.
A language we can share with others. So if you want to see an example of what this looks like, Susan Sontag's writings about photography. So Susan Sontag is not a professional photographer, but she lives with somebody who is a professional photographer, and she's ended up with this language for criticizing and analyzing photography as a result that actually makes sense to photographers. And I think one of the things we need to start working on is a language to let other people who aren't programmers still think about the computation we're doing for them and how well that's working and how beautifully that's working.
Yeah, but even with art and photography, you will get a vast number of people who will look at a piece of art and photography and say, I don't know why it is, but I just like that one and I don't like that one. So most of the general population do not have a discourse that allows them to talk about it in aesthetic terms.
True, but I say more people can have an appreciation of the aesthetics of a photograph than an application.
Yeah.
And I think we need to fix that. I think we need to start thinking about the amount of power that programming gives us. So there's a wonderful thing I like, which is Archimedes, give me a place to stand and I'll leave it long enough and I will move the world. The thing is, we already have that place and we already have that lever. I'd like the rest of the world to know about this lever, to know that actually with programming, with computers, you can change the world, you can move the world, with very simple things. But we don't tell that story enough.